Welcome back to UC Davis Live after our summer hiatus. Good afternoon, I'm Satirius Johnson. Fire has always been part of the Western landscape, but the fire season is getting longer and more severe every year. So far this year, California has seen 4 of the largest wildfires in its history, and the Dixie Fire, the second largest in state history, is still burning after 2 months. And fire will be part of our future. So what can we do to protect homes, neighborhoods, and communities and make them more resilient to fire hazards? Joining me now to discuss this is our 2 UC Davis experts. Michele Barbato is a professor of civil and environmental engineering and co-director of the Climate Adaptation Research Center at UC Davis. He studies natural hazards to buildings and other structures, including fires, earthquakes, hurricanes, and tornadoes, and how structures can be designed to be more resilient to such hazards. And Jim Thorne is a research scientist with UC Davis's Department of Environmental Science and Policy. He's a landscape ecologist with interests in regional planning, conservation, and climate change adaptation and mitigation. Welcome to you both.
Thank you.
Good morning. Thank you.
So before we get started, I just wanted to remind viewers that this is a free webcast. You can watch it live and watch it after the live broadcast on the UC Davis Facebook and YouTube channels. We're aware of others posting links saying you have to pay to watch this video. Please do not click on those links. This is a free webcast. So Michele, let's start with you. What are some steps you can take to protect your home from wildfires?
Sure. There are several things that we can do with the existing houses in order to harden them. There are some actions that we can take on the structures itself, and there are some actions that we can take on the defensible space around the house. And this is really connected with how the houses burn during wildfires. They can burn because of direct contact with flame, they can burn because of the heat radiation, or they can burn because embers are reaching the house or penetrating the house and then burning it from the inside. So in terms of defensible space, there are really 3 different regions around the house. There is a very small region, about 5 feet around the house, where you really want to get rid as much as possible of anything that can burn. Then you have a second layer of protection, about 30 feet around your house, where you need to cut your grass, eliminate everything that is on the ground that could be burned, remove a stack of wood and things like that. And then there is the larger protection or defensible space around your house that is about 100 feet, where you need to keep your trees well trimmed, separate them, keep everything that could burn, that is dead grass, dead wood, in good condition, and remove it from there. And then there are things that we can do on the house. So we can protect our roof with a layer of material that doesn't burn. We can put screens on our vents. That's a very important thing in order to protect the house from embers. We can use non-combustible material to protect the envelope of our house. We can do things like that also for decks, if we have a wood deck around the house. And then we need to make sure that all of the possible entries for embers are as protected as possible, because once something starts burning from the inside, there is no way to stop it. So these are mainly the things that we can do. And there is actually a chapter in the California Building Code, the Chapter 7A, that provides all of these instructions for new buildings. But these can be applied in a certain way also to existing building for the retrofit and for hardening existing houses.
So it sounds like some of these options can be done fairly inexpensively, but others, maybe when you're talking about materials and adding things to your house, maybe to the roof or something, that could be more expensive. Are there any kind of either incentives or government programs to help people to retrofit their existing homes to become more fire resilient?
There are several programs. I don't remember exactly how they are called, but there are several programs that are giving incentives for this type of hardening. I don't remember them on the top of my mind, but you can find a lot of information regarding these programs, for example, on the CAL FIRE website. There are information about programs. There are also free documents that describe each of these actions that you can take on your house independently or with the support of the state and the federal government.
Right. And when it comes to new construction, are there options that are there that are not for in existence for homes that are already built, like to make them more resistant, like maybe just using some of those materials as original building materials, and how much more expensive does that make the home?
Yes, so there are several aspects that can be seen here. The most typical construction for houses is wooden construction, which by itself is not fire resistant. However, even with that type of construction, by following the requirements in Chapter 7A, we can make a house that is ignition resistant. That means the house doesn't start burning very easily, so that if we have protected the house with this defensible space that I described before, ideally the wildfire will pass through it without attacking and destroying the house. There is also research that is ongoing to develop houses that are fire resistant. Now, the common wisdom is, oh, these houses are too expensive, so we cannot do it. Here at UC Davis, we are actually doing research to make new materials available that are fire resistant and that have a cost that is comparable with the existing technologies, so that not only people that can afford it will be able to build actually houses that are fire resistant. And one of these materials is part of what my research group is investigating is earthen buildings, and particularly compressed and stabilized earth blocks, which is a type of masonry construction that is affordable, that is safe, and that is sustainable, because it's fundamentally built using the soil that is available locally. And you can build obviously walls that are non-combustible. So when your walls are non-combustible, it becomes much easier to defend the house.
So these are, just to kind of explain it, these are basically bricks that are made out of soil and some other materials to kind of make it like almost like a traditional brick.
That is correct. They are fundamentally local soil, water. There can be some additions in terms of fibers, and then depending on the composition of the soil, you may have to add cement, lime, or we are also testing other materials. But right now we have verified that with cement and lime, we can obtain appropriate strength. Based on research that we have done that was funded by the National Science Foundation, we have already developed methods of designing these structures for hurricanes, tornadoes, and earthquakes. And now, as a part of a larger project that was funded by the University of California Office of the President, we are also investigating how to make sure that these houses perform well during wildfires, not only in terms of not burning, but also in terms of retaining their strength after the wildfires has passed through, so that they can be reoccupied safely by people after a wildfire.
That's really interesting. And these are, you can use these bricks to build like a 2-story home, no problem.
So we have tested that fundamentally for 1-story buildings, but we have also made calculations that would allow us to build a 2-story home in a seismic zone because the difficulty with this material is understanding exactly how much reinforcement you need to take some types of lateral loads like earthquakes, as the material is typically brittle like any other type of masonry. And so you need, in seismic zone, you really need a reinforced masonry type of building.
Right, interesting. So now if we are able to make buildings more resilient to wildfires, how could that affect climate change?
That's a very interesting question, actually. This is something that we are investigating with this project funded by the University of California Office of the President. This is a multidisciplinary project where we are working with 5 of the UC campuses, 2 of the national labs, and external collaborators to investigate what is coming out from the smoke of a house that is burning in a wildfire. Our hypothesis is that what is coming out is significantly more toxic than the smoke that is coming out from normal vegetation. And it has also a much higher impact in terms of effect on climate change. We don't have yet the entire results to say exactly what is the effect, but what we seem to be obtaining now is that even though the amount of material that is burned is much less, the toxicity of this material is much higher. And when you account for that, the advantage that usually is found in a life cycle analysis of building a house with wood actually changes completely, because if the house is burning, you are producing much more carbon than during the process of construction and during the operation of the house. So if you can avoid houses burning, it has also a relatively big effect on climate change.
Just a reminder, if you're watching live, we are taking your questions. Just leave them in the comments section and we'll work in as many as we can. We do have a question from Rob, who's watching on Facebook, who asks, how effective are some of the fire retardant paints when applied to a wood-sided house?
I think I'll get that. I personally didn't investigate the paints for fire retardant. But fundamentally, Chapter 7A is recommending not to count only on that on saving your house. And that is fundamentally saying that, yes, they can help, but they are not a silver bullet that can resolve the issue that is much more complicated. It's only one of the many tools that we have available, and you cannot count only on that.
Okay.
But I don't have exactly the information on what is their effect, and I imagine there will be some variability depending on which one is being used. So just a caution note, you cannot count only on that when you're trying to protect your house.
Right. So Jim, your work involves regional planning. How do planning decisions affect how communities are vulnerable or resistant to wildfire?
Well, I think that might relate to where the community is. So if you're a community or a neighborhood in Sacramento or in a big city, or a community in the suburbs, or communities that are out in more rural areas, because there's the carry-on effect, or there's the effect of wildfires, and wildfires obviously are going to be more prevalent, although they're starting to impact larger and larger towns. We've seen the large town of Redding in the northern end of the Sacramento Valley threatened on several different wildfire events and burns along the edges of it. We've seen smaller towns, of course, Paradise being perhaps the most well-known example, but quite a few wildfires that have swept through smaller communities. So, I think planning probably is somewhat relevant to where your community is, but you extend the home hardening idea to an entire community. So if you're in a rural area, then you want to be looking at the escape routes. And so we've had Caltrans, the Department of Transportation in California, is very keen to make sure that evacuation routes are clear in the event of a catastrophic or an evacuation because of a wildfire. And so understanding what your evacuation routes are is part of it. And then how do you treat the landscape around a community? If we talk about a rural town, how do you, what kind of a buffer does the town need? Just like there's a buffer around a house, what kind of buffer does the town need? And then how can you perhaps even look more aggressively and treat landscapes to reduce the fuel loading that is in them? Because we have, wildfires are essentially being driven to larger and more severe conditions because of a variety of factors. One of them has been fire suppression over the last 70 to 80 years, where we've tried to put fires out. And so the fuels have built up in many of our fire adapted forest types. And then on the other side, we have increasingly intense droughts and stronger winds. And so just this year, we saw 2 wildfires that carried embers across the entire height of the Sierra Nevada from one side to the other. And the Caldor fire had embers that were flying across a valley at the bottom of which there were houses, right? So it came up to the edge of the Tahoe Basin, and then the winds blew and they carried embers all the way across, and those embers didn't fall down on the houses. But so we are facing a situation where there's increasing risk coming from outside. And so communities really need to be considering what type of a buffer would make sense to allow for appropriate response times. And then how can they engage? And there's a lot of multi land manager alliances that are being built. And an example would be the Department of Transportation and the U.S. Forest Service. Well, the Department of Transportation needs to take care of roads, and they have a small thing called a right-of-way, which is about 30 yards that they are responsible for. And they could go in and treat the vegetation there to have a lower fuel load, but they need to get out beyond that because that's not a big enough type of a barrier. And so working with a county or with private landowners or with the U.S. Forest Service, if you're up in the Sierra Nevada, these are the types of communication and coordination that are needed to build a more resilient landscape. So I'll pass it back to you with that at that point.
So I'm kind of thinking of, when communities have been dealing lately with more incidents of flooding, where 100-year floods are now happening a lot more frequently than 100 years. And some communities have basically decided, well, if a community or a neighborhood is going to get washed out time and time again, maybe we should not allow rebuilding there again. So maybe we should, change that as far as our planning goes. Are we there yet with wildfires?
Oh, that's a very painful question, because if you're living in a place and you've moved to that location to be a little closer to nature and to be in a lovely bucolic setting, then there's a lot of attachment and I think emotion that goes with that question. But we do see, for example, that insurance companies are less and less willing to provide fire insurance. And in fact, the state of California just required the insurance companies to reissue to actually enforce or to permit fire insurance in areas that have had fires already. So there are strong economic arguments that are going on to say, well, the emotional side of this is one thing and the economics is another. And I don't know personally whether we've reached that point. There's this idea of that you could actually bring things into some level of better resilience or lower risk by treating the vegetation. What I mean by that is prescribed burns or thinning or grazing, things that reduce the amount of burnable material in the natural landscapes, right? And so, but even there, if you come back to the house level and you say, okay, well, you need a certain number of feet around your house, that's assuming a fire that is under certain wind conditions, maybe let's say up to 20 miles an hour. But if you have a 60-mile-an-hour wind because winds are becoming stronger, then maybe you would need a larger buffer, right? Or maybe we need some new approaches of looking at these things. And it might not mean that communities have to move entirely, but it might mean that there has to be some adaptations that are recognizing the increasingly rapid pace of climate change. So it's a balancing act here. I mean, I'd say you, on the one hand, we forest managers have for decades now in California been advocating to increase the pace and scale of these forest treatments. And the state is committing to do some of that. A lot of it is on federal lands. And so the federal agencies also have to step up to the plate to reach that greater level of resilience. And then I think we need to be looking at things that like shaded fuel breaks, which are on ridges where you've cleared some of the vegetation. And if a fire was coming, you could get in and put in a fire line more easily because there's less material to deal with. And we could look at the entire landscape that way. So there's towns that are spread around and we have roads. Roads are typically the default fire line defense mechanisms, and the heavier roads, the larger roads are actually part of our national security network that are required to stay open. Highway 101, for example, in the Sonoma and Napa fires recently was, that has to stay open. And so then if you have a linear network like that, you could say, where do the towns sit relative to the pattern of our roads, and where do those, how does that fit against where we think the fires might come from? And getting a little bit more, a little broader context or a broader view of, hey, this is our community, and how far out do we need to look, and at what different systems do we need to look to ensure that we have the maximum fire resilience?
Just wondering if you could explain, and maybe there's no reason for it, but I'm wondering, why did we move away from things like prescribed burns?
Oh, well, that has, it goes all the way back to World War II. And as we came out of World War II, the idea of wildfire was something that was, it still is. It's scary, it's damaging, it's impacting. And, Smokey the Bear, we all grew up with put fires out. Fires are dangerous, they're bad. And so we got really good at putting them out, right? We got really quite effective at putting out fires and preventing them. And there was a lack of recognition that in the Western US, west of the Mississippi, starting in the Rockies and coming across, that many of our forest types are fire adapted, and they actually need some fire to come through on a recurring basis. It's a natural adaptation. And so when I say that forest scientists have been advocating to reintroduce fire, it's to try to bring some of that back in. Now we face this difficult challenge of we need to bring it back, but we're also in hotter and drier conditions than we have been. And it's more difficult to implement those types of prescribed burns. And there's many hundreds of thousands of acres that are needed to be treated. So it's, you can pull a 40-acre burn off and go, wow, hey, we did it. But no, actually, there's a large landscape that it's generally, I think there's a consensus that yes, we need to get there, and perhaps towns and other communities offer an opportunity to start landing in different parts of the landscape and then grow our treatments out from those areas. So, there could be, I think there will be a lot of synergies that are coming out between communities that are planning for resilience, and then looking at our broader landscapes and saying, really, we have to treat our broader landscapes to bring these things get ourselves into a better, lower risk area with regards to wildfire.
Michele?
Yes, I wanted to actually chime in just another consideration regarding the previous question on if we have reached yet the point where some places are just not appropriate for building new houses. There is a possibility that some places in California, in the West Coast, have reached already that point. But there is another layer of complexity that makes that type of decision even more difficult, and that is the question of equity and justice, because often the places where that happens are places that were initially built upon because they were cheaper than other places. And we are living an housing crisis for the last 2 decades that are really pushing toward building more in the WUI for economical reasons. And that obviously increases our risk, because now we are having the wildfires hazard that is increasing due to climate change. And at the same time, we are increasing our vulnerability because we are putting more houses, more infrastructure, more electrical lines in places that are subjected to this higher risk. And so it's a very difficult decision, and it involves different layers of things that are not only based on the science. It's also a question of economy, it's a political question, it's just real life, real world. It's complex, sometimes more than we would like to admit, but it is the real situation in which there are multiple considerations that need to be made.
Right. So I know we kind of covered this a little bit, but I was wondering if we could kind of go over, like, what are the factors that are driving more severe fire seasons? Like, why has it gotten so much worse in just the last few years?
Okay, well, I'll jump in on that. So in the tree record, so we can look at the tree rings to see what types of droughts we've had in the past. And we've had some very long droughts. The blue oaks that ring the Central Valley have been studied, and there's some quite extensive droughts that they survived, that those trees survived. We had the most recent drought that had an ending point. We're in a new one now. 2020 and 2021 are this year we're about 40% under in Yolo County here from our average rainfall, just for the rainfall year that just ended. But from 2012 to 2016, there was a drought, and it was much warmer. We've had global warming is happening, and nighttime lows are warming in California by different measures, anywhere around 2.6 degrees or so of Fahrenheit of warming have happened historically. And so in that 2012 to 2016 drought, we had a massive tree mortality event. We lost about 100, but to the most recent count, about 160 million trees. That's about 8% of all of the forested trees in the state of California. And those trees, some of them in the Southern Sierra just were so dry they just died. So physiologically they were stressed out, but they could also be attacked by bark beetles, and a much larger number of trees were impacted by becoming incapable of defending themselves, because they defend themselves against the bark beetles by pushing sap out through the little holes that the beetles are drilling into the bark. But if you don't have enough moisture to create the sap, then you can't protect yourself, and the beetles can tell that. And so there were large swaths that were killed because of that. Okay, well, these are already dense forests. Now you have a lot of kindling that is out there, and you have these extremely dry conditions, and you have higher speed winds in some places. that are the winds themselves can cause ignitions if they cause a tree to fall on a power line. We have other sources of ignitions, human activity, sparks, and we also have lightning events. And the large fire events that we had in 2020 were arguably related to a climate change event where we had tropical moisture coming up from along the coast. It got sheared off because we were in a heat wave, and so the cloud deck was above 10,000 feet. Below it, it was hot, dry air. This cloud deck then got heated up, and it created lightning, and it created thunderheads. It actually rained, but the rain evaporated before it hit the ground, and all the lightning came down, and that set off the wildfires that we saw in 2020. Many of the large wildfires, and those went all the way up to Idaho. So you have all of that occurring, and you have this denser forest because we haven't been clearing out with prescribed burns that also increase the risk. So there's an ignition component to this, and then there's what happens after you get an ignition. And if you have a strong wind, and that's what we're seeing, in Napa and Sonoma, where the fires there behave very similar to fires in Southern California with the sundowner winds, where these strong winds were coming down canyon and just sweeping along the embers in front of them. And so we're starting to now see also some emerging, the firefighters and fire scientists would call it new fire behaviors. So a pyrocumulus cloud is a cloud, you've probably seen them on the TV, where there's embers and the cloud itself has a lot of the wildfire in it, and it's just getting moved along, right? And so we have this larger scale that is sort of emerging, but I would say that those are the major factors that are at play with regards to, we've got ignitions, and ignitions can come from humans and around towns and urban areas. They are much more human driven than natural. And then we have lightning strikes, and then we have this combination of a lot of vegetation, super dry conditions. Some of it's already dead, so it's even more like kindling than it might have been previously. And so that's where I think the urgency that you might hear from forest scientists is coming from of, wow, we really got to get our act together and start to figure out ways to treat this landscape. And one of the things that I'm interested in as a landscape ecologist is to say, okay, well, then if we're looking at these larger patterns that are coming out with regards to the fire risk, how do we design landscapes that would get us to have more natural breaks or have more interruptions of a fire event should one occur? And so then that's where, coming back to the towns and the urban part, if you were buffering around the towns and you were looking at your evacuation routes, that's already the beginning of a network that could be imagined across a landscape that helps to kind of compartmentalize it. As an ecologist, I would also say we don't want to completely compartmentalize. We want animals and plants to be able to disperse across these things, but we also need to start to figure out what that puzzle is going to look like.
Right. It sounds like a perfect storm of all of these different factors coming together. Let me ask you, when it comes to the strong winds, do we have strong winds now because of the warming oceans? Do we feel like this is going to be pretty much the new reality, or is this maybe just a temporary condition?
Oh, well, California has always had some pretty strong winds, and I'm not a wind scientist, and I think that they would say that the final word is not out as to the influence of global warming on wind in California. But what we have seen is that there are some of the fires that have occurred in Northern California have had similar wind signatures to what used to be quite thought of as a Southern California phenomenon. So in Southern California, you get these strong winds that come down out of the mountains towards the coast. And there are, in the fire record back into the 80s, there's wildfires that have come down the canyons that are driven by those winds. And we have seen similar types of fires being moved, both the campfire and the Tubbs Fire and other fires in the Napa and Sonoma area. And then this year we saw fires that were actually started on the west side of the Sierra and kind of went the opposite direction and went up all the way up over the top. We've had two, the Caldor Fire and the one further north that actually Cal Fire was saying it's the first time we've seen a fire go from one side of the Sierra Nevada all the way to the other, right? And so there's a lot going there, and I would say I'm not the expert to really pin that down, but I am looking at, it seems like we have some pretty high winds that are occurring when these things happen, and a lot of times our fire preparations are based on an assumption of, hey, if you clear 100 feet around your house, you're good, but that is there's probably an assumption of the wind speed that's associated with a wildfire event to which you're protected. And that's sort of analogous to what a insurance company might look at in terms of a risk-based approach to thinking about, what's a tolerable level of risk. We can't just clear everything for 2 miles around our house and go, okay, now we're done, right? Mm-hmm. But what's a tolerable level? And then, I think the engaging question is, and how do we maybe build out a landscape that doesn't have to chop everything down, but that reduces those risks and sort of incorporates some of that to reduce them.
Michele, did you want to chime in?
Yeah, I wanted to add a couple of considerations. One, regarding, Jim described very well the side of increased risk that is driven by the hazards, where you have all of these chain effects that are very often combining and multiplying the effects. For example, another thing that is driven by climate change is that during the winter, we often do not reach cold winter that are cold enough to kill the population of bark beetle to more manageable levels. And so you have this population of animals that are increasing, and they can attack multiple times the trees until they are able to actually kill them and transform them into material that will just burn during the next wildfire. But there is also another part of the equation that we touched upon before, that is the vulnerability that we are putting into our forests. The more we build in places that are prone to these high wind, drought, and wildfires, the more will be the losses. That there is no way around, because you are putting more stuff, you will burn more stuff. If there is nothing in the forest, probably we wouldn't be worried as much. Just 20 years ago, wildfires was not one of the major elements in the cost of insurance for a house. And now there are entire zip codes that are almost uninsurable from the point of view of the insurances. If you are building in places that are dangerous, then you will have to take a higher level of risk, or you need to make different types of decision. So it's really a two-element equation. There is the hazard that it is driven by climate change, and then there is the vulnerability that is driven by what we decide to build and where.
We do another viewer question, and if you are watching live and you'd like to ask a question, just leave it in the comments and we'll work in as many as we can. Case watching on Facebook asks, what's happening to the marine layer and what's the impact to trees locally in Yolo County and coastal trees?
Well, so the marine layer, the cloud deck that can be pulled in, and here in Davis, we benefit greatly from the Delta breeze, where you have a temperature discord, if you will, between the ocean and the land. And so in the daytime, land heats up faster than the ocean does, and the air above the land starts to rise, and that pulls in moisture, cooler air from the ocean. And then the cycle reverses at night. The land cools down faster than the ocean, and you can get a reversal. And so, if you're in San Francisco, you can watch the fog come in, rolling in, around 1 o'clock, 2 o'clock on a summer day, and then it gets pulled out by about that time at night. And so that's the edge of the continent dynamic that's going on. Okay, there are trees like the coast redwood that live in that fog belt, and so we have a whole forest type that is adapted to getting some of its moisture from that type, and I think that's an active research area as to, are we getting less fog? Are we getting less moisture coming off the ocean? It would make sense that if the oceans warm up, if we get a warmer ocean temperature, there's less of a differential, and that might not be a less strong type of a situation. The other thing that comes into play is the relative humidity in the air. And so during the drought, we've had very low levels of humidity, and those have extended pretty far towards the coast. So, you get right down onto the coast and there's still higher humidity. But in Yolo County, we have quite dry conditions. And I would say also, just for Yolo County, it's kind of interesting. The winds that we get that come out of the north are seasonal winds in the spring and the fall that are from the north to the south. Those winds are much faster along the west coast, along the west side of the county at the edge of the coast range than they are here in Davis or in Sacramento. So there's actually a bit of a Bernoulli effect, and those winds are going much faster along those areas at the edge of the coast range. So I don't know if that exactly answers the question, but I would say that we are drier here than on the coast, and that there's some risk of that continuing.
Right, and the impact to trees would be?
I think the impact to trees was that we were, we had higher levels of drought stress here than you would have if you went over to the coastal ranges in Humboldt County, for example, just to get a really different area. But there's still more moisture over there.
Right. So I guess to wrap up, I'd love to hear from both of you on how much of the risk you believe can be avoided or mitigated using all of these different, techniques.
Michele, you want to go last, and I'll jump in?
Okay, sounds good.
Then you can wrap it up. So I think we have to move, right? We have to be active on this. We can't just study it, and that's an unfortunate location to be. But I think that we, under climate change, everything we do is an experiment. If we do nothing, we'll see how bad that is. If we do something, we'll start to understand what the risk reduction steps that we took, how effective they were, and then we're going to have to adapt as we continue into the future from that. So I would say that it's worthwhile. I think it's worthwhile to do things both for fire and also for drought, and that we need to be initiating those and be as creative. We need as many creative people as we can get to be thinking about it and to be working on it.
Yeah, let me take these starting from a wider perspective and then focusing more on the issue of wildfire. But let's start with the climate change. There are really two different things that we can do regarding climate change. One is mitigation and one is adaptation. For many years, there was a relative push toward mitigation, and the adaptation was almost a bad word because people were thinking if we start adapting, then we don't have enough resources, a will to do the mitigation part. Unfortunately, now we are in the situation where mitigation by itself will just not take us out of the hole. And we need to think very deeply in terms of society, how we invest our resources in adapting to what is already changed and will necessarily change for the next 20 to 30 years. Because even based on the latest IPCC report, we see that there is some damage that will take thousands of years to repair. So we cannot really think to do too much about that, but there is some damage that we can avoid 20 years from now. And we should do everything we can to do that. So we need mitigation, we need renewable energy, we need ways of reducing our energy consumption. We need to go back to more sustainable materials, more sustainable ways of living. And with all of the issues and difficulties that are connected with that. But at the same time, we need also to adapt to what has already changed and what will change no matter what we do now. And so at that point, adaptation is a very nuanced way of trying to reduce the damage that we can reduce, but also try to reduce the effect of the damage that we won't be able to reduce. So what happens in terms of wildfires? We have a lot of tools that can be applied and used now, and we should. And that is something that we have discussed today. We can harden our houses, we can protect our properties and the communities, but we also need to start working on the health of our forests, because we need the prescribed fires, we need all of the tools that we can use to bring our forests to a healthy environment that unfortunately is not the current condition. And then we may have along the line to take difficult decisions. That is, as you were suggesting, there are places where we should not build anymore. So what do we do and how we help the population that now will be displaced if we make that decision? It's not something that we can say, okay, no one builds there and whoever is living there now it's on their own. That's unfair, is unequitable, and should not be a type of decision that an advanced society should be taking lightly. But all of these requires investment that is not only economical, but is also investment in terms of minds, expertise, and people that are working to achieve these results. And that affects, for example, also how we are doing our research, because for many years, a lot of the research that is very specialistic has been rewarded a lot. And that's very important, because that's how you advance the basic science. But you also need to develop more and more groups of researchers that are multidisciplinary, that can look at these problems in a more holistic way, because there is no one that individually can solve any of these problems. We really need to work together in academia, in industry, politics, non-governmental agencies, population. We need to recognize the problems, and we need to work together toward a solution.
Absolutely. I mean, this is a problem that we're going to be facing most likely for many years to come. So unless we kind of act together, it's not going to be easy to tackle. This conversation has been really great. Thank you so much for coming on today and sharing your very important work.
Thank you.
Thank you.
Our pleasure.
Michele Barbato is a professor of civil and environmental engineering and the co-director of the Climate Adaptation Research Center at UC Davis. And Jim Thorne is a research scientist with UC Davis's Department of Environmental Science and Policy. Until next time, I'm Satirius Johnson, and this is UC Davis Live.